Sometimes it is very necessary to discretize or separate the data into small bins for analysis purpose. Pandas provides cut and qcut method to discretize the data values. Let us see the dark string of Pandas cut and qcut methods. The dark string says it bins the values into discrete intervals. Use cut when you need to segment and sort data values into bins. This function is also useful for going from a continuous variable to a categorical variable. So it accepts x, bins, write, labels, ret bins, precision, include underscore lowest, duplicates. Let us see some of the important parameters. X, array-like object. The input array, that means the input series to be binned, must be a one-dimensional. So we cannot use two-dimensional object like data frame. We can use series. If you want, you can extract the series from the data frame. So then it becomes a one-dimensional object. Then you can use. And bins, integer or sequence of scalars or interval index. The criteria to bin by. It accepts integers, sequence or scalars or interval index. So write, it is an Boolean object, default true, indicates whether bins includes the rightmost edge or not. So like this, parenthesis and square bracket, they indicate the right edge or the left edge. If right is equal to true, then the bins 1, 2, 3, 4 will be binned like this, between the range 1 to, this is the right edge, it starts and closes. Labels, it accepts array-like object or Boolean type expression, and it is optional. So it specifies the labels for the returned bins. So that means instead of using the range, say for example 1 to 2 or 2 to 3, 3 to 4, we can assign the labels, say for example pass, fail, first class, etc. And then precision, it is an integer and by default it is 3. The precision at which to store and display the bins labels. It also accepts duplicates and it is optional. Let us keep this information in a separate window. Now assume that a certain number of students have scored marks between some range for 100. So that means from 21 to 61. Let us divide these marks into bins of different sizes. That is from 30 to 35, 35 to 45, and then from 46 to 60, and then from 61 to 100. Let us create a bin size first. So here I am creating the bin size. As per the DAX string of the pd.cut method, the first parameter is the x, that is nothing but a series input array to be binned. So here I am passing the series, students marks series as the first array to be binned, and then bins the criteria to bin by. So it accepts array-like object, that means sequence of scalars. Sequence of scalars means an array-like object. So here I am using a sequence of integers 20, 35, 45, 60, 100. These are the bin sizes. List is also considered as a sequence, hence I am using list. So as the second parameter according to the DAX string of cut method. So let us print this and see how it looks. If you look at the data of output, it contains a categories, 4 categories. So the interval are 20 to 35, 35 to 45, 45 to 60, and then 60 to 100. There are 4 categories. And each value of the student's marks is identified and assigned its category. Say for example 21, the first marks belongs to the category 20 to 35, and the second value 22 falls to the category 20 to 35. If you observe 37, it falls to the category 35 to 45. And if you observe the numbers, that means mark 61, it falls to the category 60 to 100. And if you observe 41, it falls to the category 35 to 45. Whereas 45 between 35 to 45. And finally the last marks 32 falls to the category 20 to 35. So there are 12 lengths are there, that means the 12 values are there, or 12 labels are there, 21, 22, from 21 to 32. These categories are named with the code internally in the form of an array-like object. And in the output, the categorized data values are assigned a code to represent its category. Let me display these codes using codes attribute. The Python index starts from 0, hence look at the data category. The category 20 to 35 falls to the first category, that is 0. Similarly, the second value 22, 25, 27, 21, 23. If you look at 37, it falls to the second category, 25 to 45, and that code is 1, because there are 4 categories are there starting from 0. First category is assigned 0, and the second category 35 to 45 is assigned 1, and the third category is assigned 2, and the fourth category is assigned 3. Notice that there is no value between 45 to 60. There is no 46, 47 or 50 in between 45 to 60. So there is no code with respect to that value. If you observe the value 61, which falls to the fourth category between 60 to 100, and its code is 3. Similarly, you can analyze the other values with respect to the codes of the categories. And also, the returned discretized object as a categorical data internally. So let me display this category using the categories attribute. The returned object has the 4 categories: 20 to 35, 35 to 45, 45 to 60, 60 to 100. And observe the type of the closed is equal to write. Data type is interval and closed is equal to write. That means according to the text string, the closing edge is right, that is square bracket. If we make it false, as per text string, write is equal to true. If we make write is equal to false, then the closed edge will shift to the left. That means the square bracket will shift to the left side. Now let us count the values fall under different categories or different bins, that is computing the frequency of occurrences of values within bin size using counts method, value underscore counts method. We have 8 values belongs to the category 20 to 35 and 0 value belongs to 45 and 60, which is really true, right? Here we don't have the value which falls to the category 45 to 60. As per the text string, the parentheses represent the side which is open, a consistent mathematical notation for interval representation, and square bracket means it is closed. That means the bin size inclusive. The square bracket indicates inclusive. By default, it is on right side. If you pass right is equal to false, inside the cut method, then you can observe the square bracket in the left side. Let us use right is equal to false for the previous example to show how the interval closing works. Here you can observe closed is equal to left. Earlier it was right, and you can observe the parenthesis and square bracket. Both have been interchanged. And the frequency of occurrence of the values also according to the new inclusive method. That means, say for example, between 35 to 45, 45 will not be considered. That means not inclusive, because we have first right is equal to false. Hence it is not inclusive. So between 35 to 45, between 35 to 45, now we have only 2 values. Now to observe the important thing, between 45 to 60 we have 1 value. Earlier it is 0, because we have passed the right is equal to false, hence the left starting bin size is inclusive, hence 45 has been included. while counting the bin category between 45 to 60. So hence we got one value between 45 to 60, that is 45. Between 35 to 45, now we have only two values, that is between 35 and 45, 37 and 41. 37 and 41. Only two values. They fall to the category 35 to 45. We can also use our own bin names by passing a list or array to the labels parameter. So according to the DAG string, it accepts labels. So it may be an array-like object. So specifies the labels for the returned bins. So instead of using the category like 30 to 20 to 35, 35 to 45, 45 to 60, 60 to 100, we can use our own labels. So here I am using for 20 to 35 file, 35 to 45 was, and for 45 to 60 for this category second class, and for this 60 to 100 first class or FCD, first class with distinction. Let me look at their categories and value counts. As I am passing right is equal to false, we got two members or two marks which falls to the category 35 to 45, that is false. If I use right is equal to, if I do not use right is equal to false, I will get the category like this with file SC, FC, FCR, FCD. If there is a random or large data set is present with a different range of values which we don't know actually, in such situation we can easily and approximately or equally likely discretize or bin the data into equal length based minimum and maximum values, which is surprisingly like categorizing between the minimum and maximum values. Let me have some small random values to illustrate this. Here I have got a 10 random values between the range from 0.1 to 1.0. Now I would like to pass the integer number for bin length as a scalar value as per the DAG string. It accepts a scalar value, okay, and the series, that means series to be binned, and then precision as per the DAG string to limit the decimal precision to 1 for better analysis. For the cut method, I got an equally binned categorical data, that is 0.06 to 0.3, 0.3 to 0.5, 0.5 to 0.8, and 0.8 to 1. These are the categories, 4 categories, for which these values false. Not exactly equal, but equally likely. For normally distributed data values, we can use quantile based discretization method to discretize the data using Q-cut method of Pandas. Q stands for quantile based discretization. Let me create a randomly distributed data of 1000 values. So here I am displaying only the first 20 values out of 1000 values using np.random.randn. Now I would like to cut this data into 6 equally sized categorical data using qcut method. You can easily check the data string of qcut by your own. For the time limit, I would like to explain how it works. As you can see here, the data values are approximately cut into 6 equally sized categorical data values. That is from minus 2.96999 to minus 1.001 and minus 1.001 to minus 0.532 and from minus 0.532 to minus 0.113 and so on. Let me count how many values falls into each category out of 1000 values. Here the data indicates that it is displaying 1, 2, 3, 4, 5, first 5s and last 5 values. So here you can observe that the discretization has taken place roughly, that means approximately, or in other words equally likely, into 6 interval bins. Similar to cut method, we can also use our own quantile labels to qcut method to rename the categories. This is how we can discretize and bin the data values.